Uh, Hello, sir. My name is Kuldeep. We have a prml project. Our project title is a stock prediction, and this is my team: Sayam Kamra, Ripu, Srihari, Man, Nilesh, and me. And this is introduction to stock market analysis. In this, we have include regression and classification with fusion technique to analyze stock market trends and predictions, the future movements. Next one is objective of the project. Our main objective to analyze prediction with the use of regression classification and fusion method, achieving accurate forecasts.
So the first model type is regression models. So we tried 3 types of regression models. First, polynomial regression, second, KNN regressor, and third, random forest regression. We got the best results on polynomial regression, as you can see in the table. Polynomial regression significantly outperforms KNN regressor and random forest regressor for predictive accuracy by giving a much lower mean square error. Low mean square error implies that predictions are closer to the actual values, so it makes polynomial regression the better model for our case.
So about the classification techniques utilized for the sentiment analysis, we tried different approaches, and as you can see, we got the best accuracy for random forest classifier. Also, we tried SVM, but its high computations made us lean more towards the random forest classifier. So how the random forest classifier works? It uses the abilities of decision tree to combine their outputs of many decision trees and uses majority voting to find the final classification. Unlike SVM or KNN, it learns from different perspectives, taking output of or classification of each decision tree.
Okay, so I'm Srihari and now I'm going to explain how we have fused the sentiment output and the regression output. Okay, so the primary architecture we have used for fusion is a simple ANN. Okay, so the outputs from the regression model and the sentiment model were normalized. They were concatenated into a single vector and they were passed through the ANN so that we could predict the future movements. Okay, so this is the architecture presented here. The input layer, we just input the fused vector, which consists of the OHLC output and the sentiment output. The OHLC output consists of the rolling average and the sentiment output consists of the output that's acquired from the top 5 news of that specific day. At the end of the first hidden layer, we use ReLU activation, and at the end of second hidden layer, we use TANH activation function. And at the end of our ANN, the fusion model, it just gives the same output as the OHLC regression. And the type of fusion we have used is a combination of late and early fusion. So this is the graph that we have acquired after fusion. So as you can see, the orange represents just the simple OHLC regression output. The blue one is the ground truth, and after the fusion with the sentiment, the fusion of OHLC with the sentiment, the green dotted line is the output, which as you can see is far closer to the ground truth than the simple OHLC regression.
Hello sir, I am Sayam. So now let's talk about the description of our data. So our data basically includes the highest price, the lowest price, and the opening and close price of the present day for a particular company, and the top world news that are affecting the stock market price. We also, so these are some results and the findings of our model. Basically, our regression model was having certain high MSE as compared to our fusion model, which was made by implementing the effects of our sentiment analysis model on the regression model by reducing the MSE.
So let's conclude our project. Regression modeling is used to successfully capture time-based trends and complex price movement for making stocks value. Next is sentiment classification, pulled out meaning market sentiment from news handling, providing valuable context to inform prediction. Last approach is fusion, blend both numerical data and textual insight, that is regression and classification, into a single well-grounded model.
Thank you for listening to our presentation.